All right. Any day now you guys are going to be in calculus, right? And so sometimes in calculus, it's necessary for us to rationalize the numerator instead of rationalizing the denominator. Really, we're just trying to get rid of radicals. Sometimes we want to get rid of them in the denominator, and sometimes you want to get rid of them in the numerator. Let's practice this time rationalizing the numerator instead of the denominator. Let's get rid of the radical in the top. Example number 5 gives us the square root of 12 over the square root of 5y. If you notice that I have a square root in my numerator, square root of 12, I want to get rid of that. I'm going to multiply both the top and the bottom by that square root, the square root of 12. If you notice when I multiply these fractions, the square root of 12 times the square root of 12 is really the square root of 144. In my denominator, I have the square root of 5y times the square root of 12, which is the square root of 60y. Let's see what happens, though, when we try to reduce this a little bit. I end up getting 12 on the top because the square root of 144 is 12. That's perfect. That was our goal, right, is to get rid of the radical in the numerator this time. But I'm not going to leave my denominator 60, the square root of 60y. I'm going to see if I can reduce that a little bit more. So let's go ahead and factor tree 60. I broke it down into factors of 2 and 30. I broke down 30 into 2 and 15. And I broke down 15 into 3 and 5. Since it's a square root, I'm going to look for groups of 2. So it looks like I have this group of 2 that I can bring out. I have a lonely 3 and a lonely 5 that are inside along with this lonely y. So my problem turns into 12 over 2 rad 15 over y. Now you may notice that I actually have 2 outside numbers. This 2 still just being multiplied by my rad 15y, so it's still just a factor of. I don't have any plus or minus signs connecting any terms. I have one term in the top and one term on the bottom. Isn't there a common factor here that I can reduce by? As long as they're both outside and they're just factors of, there's no plus or minus sign connecting, I should be able to reduce both of those by 2. And I can say that my simplified final answer, that I've rationalized the numerator, is 6 over the square root of 15y. I have no more radical in the top, and my answer is as simplified as I can get it. Maybe you noticed at the beginning that you could have maybe broken down the square root of 12 a little bit first, and then maybe you're just rationalizing the square root of 3, and you can multiply both the top and the bottom by a 3. You would end up getting the same answer. Try it. All right, let's look at B. I have the square root of 2/3. 2/3 doesn't divide evenly, and so I wouldn't be able to simplify this anymore. And if I broke it down into 2 separate radicals, it would be the square root of 2 over the square root of 3. The directions ask us to rationalize that numerator. So let's try to get rid of that the rad 2 on the top. Let's go ahead and multiply both the numerator and the denominator by that radical, square root of 2 on top, square root of 2 on bottom. I ended up with the square root of 4 over the square root of 6, but we know that the square root of 4 is just a 2. I have 2 over rad 6. You can try to reduce or factor 6, but it only breaks down into 2 and 3, and then we don't have enough to bring out groups of 2, so I have to just leave it the square root of 6. I have 2 over the square root of 6. I can't reduce either of those, so that would be our final answer there. We've just rationalized numerators, and now we've rationalized denominators.